So in the past, we've used this session mostly to focus on the core ArcGIS platform, demonstrating the key patterns of use, really through the lens of a set of business workflows. We wanted to change it up a little bit and do something a little different this year by focusing on those emerging trends and the technology innovations that are not only changing the way we all work on a day-to-day basis, but are really transforming the business landscape. We're going to showcase some of the work that our product teams and our professional services organization are doing to bring those innovations to the market. So we're going to look at a range of innovative tech, including 3D GIS, looking at the potential for integrating blockchain and GIS, and lastly, taking a deep dive into deep learning and GeoAI for understanding and potentially predicting customer behavior. We're going to start off with Nitin Bajaj.
Thanks, John and Jason. Let's talk about indoor maps for a few minutes. Why? Because I have the stage. But also because humans spend more than 80% of our time indoors, even in this weather. Also because buildings and campuses are one of the largest expenses on our books. And yet, 50% of the industry keeps their floor plan data using pen and paper. Now, this has been true for several years. So why do we care about it now? For one, in 7 short years, our workforce will be led by millennials. In this age and time of real-time data and information everywhere, these obsolete methods of record keeping are a challenge for business sustainability. We looked at a common thread that touches upon all these industries and sectors that are facing this challenge and looked at it as an opportunity. These user personas are what we are talking to and building for. As an owner, I need to know and have an insight into my business, assets, and people. I need to ensure my business is safe, efficient, and profitable. As a knowledge worker, I need to be able to provide insights to my business owner. As a field worker, I need to have mobile tools to maintain and update the facility. As occupants, visitors, employees, and students, we need to be able to get to our meetings and classes on time, efficiently, without getting lost. We need tools to collaborate and share, and be able to provide feedback to make our workplace and campus better. These personas are trying to achieve the common goal of understanding their built environment, improve collaboration and productivity. Realizing these needs, investments in smart building technology over the past decade have consistently increased. But unfortunately, these disparate data systems don't talk to each other, leaving these user personas in a flood of data points and systems, but no real insight or a system of record. Imagine a precise map of this conference with a blue dot that shows you your current location and allows you to find and search a location, an event, or a room. Here, I'm doing a search for the nearest Starbucks, and it'll generate a route irrespective of the floor you're on or you want to go to. Imagine the power to use your fellow employees as sensors, giving them the ability to report issues around your corporate campus. Here I'm reporting a broken projection equipment. As you see, it picked up the date, timestamp, and my current location. I took a picture, added a description, and I sent it along. How did we do this? So this is ArcGIS Pro. I'm using a georeference CAD for one of our multi-story buildings on the Redlands campus. I brought the floor plan in, and I run it through our floor plan to indoors tool to bring it into the ArcGIS Indoors information model. I'll do some checks. I already ran this in the interest of time. I'm doing some checks to make sure the data came through as expected. And then I'm going to enrich this with network information and points of interest data, such as ATMs, fire extinguishers, and people information. Once I have that information in, then I'm going to generate routes with preferences for elevators, stairs, accessibility restrictions, and even generate directions based on landmarks. It's going to come up here in a sec. So this is my multi-stop route, and I have preferences built in. And next you will see the directions which are based on landmarks. The data that we generated using the floor plan to indoors tool is ready for use in 2D and 3D applications. As you can see, this is a true 3D network that you can use for routing between and within buildings. As you saw, ArcGIS Indoors is a complete indoor mapping system that helps you assemble, manage, and share building and campus information. This is a huge opportunity, and we truly believe in it, and we are creating a new partner ecosystem around it. Our partners are helping us deliver and extend this ArcGIS Indoors system, and many of you are in this room today. Thank you.
Thanks, Nitin. Nitin showed us some very exciting examples of using ArcGIS inside of buildings. Let's take a step back and think about the use of buildings more broadly. I'm very excited today to give you a sneak peek into something that we've been working on as part of ArcGIS Urban. It's a prototype designed to help developers, investors, and landowners to rapidly test the financial feasibility of real estate development projects. And in an industry that represents $1.3 trillion in annual economic activity, having the right information at those critical decision points is absolutely crucial. Typical development workflows take place in 4 stages. In the pursuit phase, an investor or landowner or developer will be evaluating a parcel of land and trying to identify the use cases and types of buildings they could construct that could deliver the highest return on that investment. Now, mixed in with all of that are complications such as local zoning codes, construction costs, and pro formas that they use to actually estimate those financials. All of that is used to support a go or no-go decision on the project. If it's decided to go for the project, we move into pre-development, construction, and the completion stages. We're going to be focusing on that pursuit stage today. It's a foundational stage where we make a lot of assumptions that set the trajectory for the entire project. Now, as we all know, real estate projects can be extremely expensive and lengthy, often hundreds of millions of dollars and years of effort. And just that pursuit stage can take weeks of effort and cost tens of thousands of dollars in research. Our goal is to reduce the amount of time it takes to get through that pursuit stage and increase the value of the information that you derive from it, creating better outcomes for investors. And we want to do that in a way that is flexible to individual requirements and financial models. Most organizations have their own secret sauce of numbers and financial models and parameters that they want to inject into this process. So let's take a look at the actual app itself. The first thing I need to do is select a parcel to evaluate. Once I click on the parcel, we'll grab the information, and we can see things like the parcel ID, some basic zoning information. And it's here that we can also put in the parameters of our project. For example, I want to stage an industrial building, mainly used for office space. And we want to set the maximum building height to 300 feet and assume that we can use 50% of the parcel coverage. In this process, the app is going to generate a model of that building based off of those parameters, and we'll get to see the output and work with it. So the light blue box represents the zoning volume. This is the maximum buildable area based off of the parcel's geometry and the zoning information that we put in. Inside is the plausible building form, which is essentially a schematic that represents gross floor area available after the building is constructed. It isn't meant to be an architectural design, but rather a way to quickly generate back-of-the-napkin math on available square footage. And we can see how the square footage has been allocated based off of the different use types associated with this type of building. For example, office space and other industrial use cases. This is just the first step. From here, we want to plug these square footage numbers into our pro forma. And we can bring that pro forma in from an Excel spreadsheet. Immediately, once I bring that spreadsheet in, we can see the profit number associated with this project. We can also see all of the different fields and formulas and calculations that are in that pro forma. And when we uploaded the spreadsheet, we're not just reflecting the values, we actually brought in the formulas. So for example, if we want to change the assumption of our cap rate from 8.5% to 10%, we can see that once we do that, the profit number has adjusted to reflect that. The ability to rapidly set up multiple scenarios reduces the round-trip cycle of schematic design and financial analysis. It makes things very flexible. For example, if I want to stage this particular parcel with a different use case, for example, let's assume a residential tower, we can see how the numbers change. We might also want to check the adjacent parcel and see how that same tower would look in terms of finances from that location. And at the end of the day, we can select multiple scenarios and generate a quick fact sheet that lays out each scenario side by side very quickly. It's like shopping for a very expensive refrigerator. At the end of the day, real estate projects are extremely complex, they are expensive, and they're very competitive. So being able to generate these side-by-side scenarios on the fly can be the difference between having the right information to make the right investment decisions and actual success. Thank you.
Thanks, Dennis. I'm joined here today by my coworker, Konstantinos. Konstantinos is our local blockchain expert, and he has just been awarded a fellowship from Jack and Laura to get his PhD in blockchain and GIS. So I'm very lucky to have him here with me. So I'm sure most of you have heard something about blockchain. And even if you don't understand the underlying technology of blockchain, you've probably heard about some of the applications. Some of the things in cryptocurrency like Bitcoin, right? But what is blockchain? Blockchain is a way to store data in a shared, unalterable ledger that records all the history of the transactions. So when I take a record and I put it in the blockchain, it's stored in multiple ledgers across many computers. So it creates transparency by default. It also provides us with a very secure environment. And that environment is allowed or provides the ability for us to make trust with all the participants. So we're probably used to centralized and decentralized network systems for the most part. But a blockchain leverages a distributed network system. And that allows them to create a process where there was no one authority that has control over the blockchain as a whole. So that creates that trust relationship between all the participants again. But when we start to look at the transactions themselves and supply chain, we want to look at reliability and integrity for a supply chain. And blockchain provides that by default. So what does blockchain provide us? It provides us with consensus. So there are no transactions going into the blockchain that aren't approved by the entire system. So it takes a multi-processed approach to get approval to put that transaction into the system. By default, it gives us provenance. So we can now trace back through and understand where something came from. And of course, because I can't change a record in the blockchain, I have to create another node if I want to update the blockchain. It gives us that immutability so that I know everything in there is always accurate. So, one of the things that we want to think about with supply chain in this fashion is that it's going to improve the efficiency and the transparency for our supply chain, but it's also going to improve some of the processes behind the scenes, everything from the warehousing and the delivery to our payment structure. Okay, so let's take a look at what spatially enabling blockchain looks like. So what you're seeing here is a sample application that Konstantinos put together. And we're showing a shipment that's going from point A to point B. Could be from your manufacturing facility out to a distribution facility. And as we look at this, what we see is each of these transactions happening. And the supplier, for instance, is putting in that transaction, what he sent, where he sent it. The trucking company is putting in where they picked it up, where they're going to drop it off, probably some information along the line about where he was. Same thing with the ports, same thing with the overseas shipping companies, right? But these transactions include with them the location and status of the shipments along the way. And since I have a perishable product that I'm shipping at this point in time, I want to make sure that it didn't exceed a certain temperature. So from an attribute information, I'm also tracking the temperature, the average temperature, and the actual temperature to make sure it didn't exceed the range I need for my product. Now, we can also take a look and understand where we're going here. So in this particular example, well, we're going to start in the Port of Miami, and we're going to move over to the Port of Rotterdam. And then eventually that product will move from the Port of Rotterdam over to our distribution center in Venlo. Now, I mentioned the transactions, and I mentioned that we're tracking that temperature, right? So one of the other things you can see here is that we've got certain areas highlighted in red. So what that's telling me is that I've exceeded the temperature threshold that I've set at 90 degrees. So I can interrogate those temperatures, and I can understand if that's had an impact on my product. Overall, what I'm trying to do is provide that transparency that I talked about earlier, so that we can look at any piece of the puzzle and understand that provenance. So what blockchain is really providing us here in regards to supply chain is that consensus. So we always know that a transaction is valid. We've got our provenance so that we can always trace back where something came from. We've got the immutability because transactions cannot be changed, and that gives us our transparency. And we have finality. So we have one ledger system that everyone can use and everyone can trust. So if you're interested in learning more about what Esri is doing and some of our other partners are doing with blockchain, we are also hosting a special interest group tomorrow afternoon at 4 o'clock over here in room 204A, and we'd love to have you all attend. Thank you.
Thanks, Kevin. My name's Whit Mateau, and last but not least, we'd like to show you some of the work we're doing in the area of GeoAI and machine learning. Artificial intelligence, or AI, and machine learning are some of the most important concepts in our world today. And I suspect many of you are already exploring how these technologies can improve your business. As you look to apply them to solving spatial problems, it can be difficult to unpack a lot of the terminology. We heard a little bit about that earlier. So to simplify things today, we're going to break things down into 3 main categories. At the broadest level is AI, or artificial intelligence, which describes machines performing tasks that require at least some level of human intelligence. Now, one engine that can power AI is machine learning, which describes data-driven algorithms and techniques that learn from data. In ArcGIS, we've actually been applying machine learning algorithms and techniques for some time. In fact, there's a collection of geoprocessing tools available out of the box today in ArcGIS that use machine learning algorithms and techniques to solve classification, clustering, and prediction problems. But as Jason said earlier, we wanted to use the time today to focus on some of the new innovations and trends that we think can really help drive your business moving forward. Which brings us to the 3rd category, deep learning. Deep learning is a type of machine learning that includes neural networks and is generally used to solve complex problems like self-driving cars or recommendation engines. Today, we're excited to show you how you can integrate ArcGIS with deep learning. So a key aspect to many business operations is this idea of travel time. This could be how long it takes your customers to reach you, maybe at one of your stores or facilities, or how long it takes you to reach the customer. At a technical level, this idea of a travel time service takes in a start or an origin, an end or a destination, and a time of day, day of week, and it predicts how long it will take to get from that origin to that destination. Now, this idea of calculating travel times has been in ArcGIS for some time. However, we believe that applying deep learning to solving travel time problems actually opens up a slew of new opportunities. And one of the main reasons for that is speed and the ability to predict travel times at scale. So what we're looking at here is a web application that lets me visually explore and analyze travel times to new or existing store locations. So in my scenario, this is downtown San Francisco. I'm looking to expand my business to downtown San Francisco. So I'm going to go ahead and add a store here in the North Beach area. Now you can see my map updates. And what I'm looking at, in effect, you can think of as a travel time service. The colors on the map visually tell me how long it will take to get from anywhere on the map to this store, or really to the closest store. Now, to see what's happening a little bit behind the scenes, I'm going to turn off streets and turn on boundaries. And what we're actually looking at are census boundaries, in this case, census block groups, that are colored based off of the travel time. And these travel times are being calculated on the fly as I interact with my map. To visualize that, each of these pink lines from one of the census block groups to my store is being calculated in real time, and that value is used to determine the color. So I can essentially see a travel time service. So let me go back to streets. I can perhaps add another store, maybe here in the Richmond district, and I can see that as I interact with the map, it's visually showing me how long it takes to get to the closest store. I can also see in the lower left, it's providing me some metrics about travel time in my map. In this case, from anywhere in my map, the maximum travel time is going to be 65 minutes, and the average travel time will be about 20 minutes. Now, this is kind of a new, neat way of visualizing travel time, but it's not that different from what we've been able to do today. So what's different about the deep learning approach? Well, it kind of gets back to the speed, which allows me to do interactive real-time analysis. So in practice, a lot of you that are doing this kind of a planning workflow will want to incorporate demographic data. So I'm going to expand out this demographic chart, and now I'm able to see the total population represented in the map I'm looking at, as well as a breakdown by gender and by age. But more interestingly, we're able to determine the reachable population. In this case, reachability has a very close relationship with travel time. Populations that are closer to the store, that have a shorter travel time, are considered more reachable. And as the travel time increases, they become less reachable because customers are less willing to drive long distances or long times in the car to reach your office. So I can see reachable population as well as total. Now, maybe I want to explore this area in the Mission District. So I can add a little viewport here. And now I can see my chart only reflecting the travel time and reachable population and demographics within this viewport. And maybe I'll tighten this up a little bit, and I'll explore all through the Mission District here. And you can see as I move around, all my demographic, travel time metrics on the left-hand side are updating in real time. Now, as a result of this analysis, maybe I've decided that I want to capitalize on some of that and move this store from North Beach down closer to the Mission. So I can select this store and drag it down. And as I drag, you see the chart and metrics update as well as the map. I'd like to remind you that when I'm dragging the mouse, all of these travel time calculations are happening in real time as I interact with the map. Now, because I'm able to do these travel calculations in real time, I can actually look at this at different days of the week and different times of the day. I think we intuitively know that travel time is dependent on time of day, especially in an urban area where Monday at 9 a.m., which is when I'm looking at this map, there's going to be a lot of traffic. So to highlight this change in travel time, I'm going to change my rendering here on the map so you can more clearly see exactly where that break is. We're going to set that to about 15 minutes. And now when I switch from Monday to Sunday, the map updates and the charts update because I can get further and I have more reachability on Sunday at 9 a.m. than I do on Monday at 9 a.m. So to date, so far, we've only been looking at a handful of new stores. But because we can do these operations at scale, I can bring in all of my existing stores, which I have here in a spreadsheet I'll bring into the map. This is about 230 stores in California. And as I zoom out, I'm able to look at the travel time surface to all of my stores. and continue to zoom out and watch the metrics as well as the map update accordingly. And just to give you an idea of what's going on behind the scenes, we have some internal metrics here. If I expand this out, to produce this last map, when I zoomed out a little bit, it performed about 32,000 calculations in about 0.4 seconds. So in this demo, we've showed how you can integrate a travel time service powered with deep learning with ArcGIS and provide a new interactive experience for planning and analysis. But we think perhaps the more interesting or powerful application of this lies in the area of operational awareness on real-time data. So as I look around the room and spoken with a number of folks, we're all clearly tightly coupled to our mobile devices, and we know that our customers are as well. Many of them are using the location services on those devices. And we firmly believe that today and increasingly into the future, there will be opportunities to improve your business by connecting with your customers in both space and time. Some opportunities for this include product or goods delivery, you traveling to the customer, service delivery, as well as mobile order and pickup. So let's see how our travel time service powered by deep learning can help with this last scenario, mobile order and pickup. This is another web application. In this case, we're looking at a mobile order dashboard. The map is centered on a store here in downtown San Francisco, and I can see these dots moving towards the store. These are customers that have placed orders on their mobile phone and are en route to pick up their order at the store. Now, I can see where the customers are, which is interesting, but what's more useful is when I expect them to arrive. This is represented on the map by the color, but also in the histogram below, which provides an aggregate count of the number of customers that are expected to arrive at my store in 4 minutes, in 5 minutes, 6 minutes, all the way to 45 minutes, giving me a visibility into when I'm gonna get a rush at my store, which I can see is gonna happen in about 23 minutes right here. Now, if your mobile ordering system also tracks fulfillment, then not only can we visualize counts by arrival time, but we can visualize order status. So here I'm able to see how many customers and which customers are going to arrive before their order is ready, right on time, or after their order is ready. And having this kind of visibility may be especially important with perishable goods, coffee, food, et cetera, where you really want to make that connection in a very tight time window. And so having this kind of operational visibility allows me perhaps to prioritize orders that are late with those that are early and make that better space-time connection with my customer. Now here I'm just looking at one store. I have a number of other stores that I can interact with. I can click over here and I can check. This one's doing a little bit better in terms of managing their operations. And I can click on other stores and get visibility into that. But at a corporate level, if I did want to see what's happening across all my stores, because we can do this compute really quickly on the fly and at scale, I can turn off the selected store and get visibility into what's happening across all my stores. Now I want to use this point just to remind everybody that the capabilities for computing travel time, as well as doing demographic analysis and more, are in the ArcGIS suite of tools today. But we think that the idea of using deep learning, in this case to power a travel time service, offers new opportunity as we look to grow this at scale. And in terms of what's next, we're working to enhance the accuracy of this model. We believe that we can get it to the point where it's as good or potentially even better than rule-based engines for travel time. And where I think the real power is in applying this to your data and learning not only generically how long it takes to get from point A to point B, but how long it takes your customers to get to your stores. And it could get to the point where it knows that it takes my wife 5 minutes longer to get to the store to pick up our favorite coffee in the morning, or even that at Monday morning at 9 a.m. when I arrive at the mall to go visit the store, that it actually takes another 15 minutes to find parking and walk through the mall to get to the store. And increasingly, I think those minutes will matter. John?